Okay, so again, this is for test review. We're creating expressions with percentages. So what we have here is Anna scored 15% more on a test than Billy. Billy scored 25% less than Carly. If Anna's score is A points, write algebraic expressions for Billy and Carly in terms of A. And you can just use B and C there in terms of A. Put these expressions in the simplest form. So yesterday you guys did a pretty good job of reading this and seeing what it means and what they're asking for. So what they're asking for here is that you have an expression for Billy with something equals something with A in it.
What's the thing between the equals and the A?
Say that again?
What's the thing between the equals and the A?
Stuff. Something.
Oh, okay.
And then what they're asking here is C equals something with A in it. Okay, so that's what they're looking for. And we're going to hopefully give that to them. Let's get rid of that. Okay, so Anna scored 15% more on a test than Billy. So how would I write that on here? Right here, yes. Bailey.
A equals 15% plus B.
So 15% plus B. Now here's a question. If you do 15%, what are you taking 15% of?
Billy's score.
Of Billy's score. So 0.15B would be 15%. Okay, so if we did A equals 0.15B, that is 15% of Billy's score. Now what else do we have to do here?
Wait.
Oh, Bailey?
You have to know what Billy's score is. So C minus 25.
Well, be careful here. We aren't quite finished with this one yet. Yes?
Why don't you do 1.15 because then you're adding.
Okay, so you have a choice here. I mean, I was going to go with, okay, that's 15%. This is 15% of Billy. But I have to add Billy's score to it. So you could put plus B, plus 1B, or B. And yes, I would have started with that.
Yeah, that would be a lot easier.
A equals 1.15B. Now just double check here. Double check that you're taking the 15% of Billy's score because she scored 15% more on a test than Billy. So you got to make sure you're taking 15% of Billy's score and adding it, which is what you're doing here. That's good. Okay? We want to make that. Actually, we'll leave that here for a second. The second part says that Billy scored 25% less than Carly. So he actually had 25% less than Carly's score. So Billy scored, and how am I going to write 25% less than Carly? 0.25C. That's 25% of Carly's. How would you make it 25% less?
75% of it?
75% of it. I like that idea. So let's go 75%, 0.75C. You could have said C minus 0.25C, right? Because C's score is Carly's score, then subtract 25% of her score from it, and that would be B. Or you can just jump right to 75%. I like that idea. So now we have A equals something and B equals something. The problem is we want...
Carly scored the highest, Anna scored the second highest, and Billy scored the lowest.
You definitely have an idea of what's going on here. But we want Billy in terms of A. So we want B equals A. How can I change this one to say B equals something with A in it? Yeah.
So it would be something in A equals B or A?
I want it to be B equals.
Okay.
So how can I change this to say...
Equals A minus B 15% times 15%.
You're doing way too much work here. This is already...
Subtract 15% of
This is already 15%. You're okay with this. This is it. This is your equations. You don't need to add more equations here. We already have equations we need. We just need to make these say B equals something with A. Kyle.
You divide 1.15 to B.
I like that. We already have our equations and our expressions. If I divide both sides by 1.15 and do a little flipping here, I get B equals A over 1.15. And that's Billy's expression in terms of A. So now that we're in algebra mode, I wouldn't go back and try to make another expression. I wouldn't try to start new. You have those. They can work. Use these. Okay? This next part's the tricky part. I want C in terms of A. The problem is this one has C in terms of B. I have C, or actually it has B in terms of C. But I have a C and B in this equation already. I want to get a C and an A. So how can I change this to have a C and an A in it? Audrey.
Replace B with A over 1.
Right, so this right here, B equals A over 1.15. So B equals that. So I can substitute that into B, and I would get A over 1.15 equals 0.75C. We're really close now. We almost have this in terms of A. The thing is we have to have it say C equals. So how can I get rid of this 0.75? Audrey?
Divide by 0.7.
We can divide by 0.75. Now,
Kind of messy.
it is kind of messy. That's a good point. So that's exactly what I was going to say, is that if you divide by 0.75 here, divide here, I get a fraction and a fraction. So I really don't want that messiness. Kyle?
Can you times by 1.15 both sides and then divide it by 4?
If you multiply, oh, so you're saying to multiply, this is not a bad idea. We can multiply both sides
Oh, yeah.
by 1.15. Let's do that.
Divide it by whatever you get, whatever seems to be one side after that.
I'm going to make some room here. So if I go times 1.15 on both sides, I get A equals, and I believe that is, actually I'm going to do that on a calculator, but I think it's 0.8625. That's my guesstimation here. What do I have? 0.8625, okay. 0.8625C. And now I can solve for C by dividing. Now, I didn't do it that way. So you end up with C equals A over 0.8625.
So that means A is 86.25%.
No, that just means that if you want Carly's score, we don't have anybody's score. But all I need now is if I have Anna's score, I can find Billy's and Carly's with one step. Just plug it in and figure it out. Now I'm going to go really quick back to this spot right here, because I didn't do this on this spot. But Kyle did, and I liked that method. So what I did here is when I had A over 1.15, another way you can think about it, equals 0.75C. And it's very similar to what he just did. But think about it this way. Audrey said I could divide both sides here by 0.75, but it's messy. Okay? If this were a fraction, which it is, 0.75 is a fraction, 0.75 is 3/4. What would I do to get rid of the 3/4? Really? I can multiply by common denominator or multiply both sides by the reciprocal. So I can multiply by the reciprocal. Now, if it were a fraction, I could do that. Why can't I do that with a decimal? You technically have a reciprocal of a decimal algebraically. If I multiply, what can I multiply this side by? So that the 0.75 cancels. I can multiply by the reciprocal. That makes sense? So what's an easy reciprocal, even though it's not formal, but what's the easy reciprocal of 0.75? Yeah. Besides that, without making a fraction.
1 over 1.75.
1 over 0.75, right? The only reason we're doing that is so we can cancel. And then we can multiply both this side, hold on a second, times 1 over 0.75. And notice how you still get C equals, multiply the top here, that's A, over, and then 0.75 times 1.15 was 0.8625. So that way will work too.